Hello. Hi guys, good morning. Welcome back to a new video. In this we're going to see problem minimum falling path sum 2. Now again a big disclaimer. I'll show you all the approaches. Again, I'm not counting the recursive, all that stuff. I'm starting off with I'll show you n cube, n square, n cube, n square. Again, another way of that. You know what I mean. N square, n square, n square, n, and then n square O of 1. So yeah, sit down, relax, and let's start the video. Now it simply is minimum falling path sum 2. If you have not minimum falling path sum 1, again, if you have watched it, then I'll for sure recommend at least go and try to solve these two variations. These two variations you should be and you will be able to solve it very easily. Again, I'll highly recommend please go and watch this video to get the entire intuition of every point. Now coming on back, again the link you can find in description and comment section. You are given an n cross n integer matrix called as grid. Okay. Now we have to return the minimum sum of a falling path with non-zero shifts. What it means is that a falling path with non-zero shift is a choice of exactly one element from each row of grid such that no two elements chosen in the adjacent rows are in the same column. What I mean is that I have to just go and fall. I have to go and fall through all the rows, but I have to fall in such a way that if I choose an element, I cannot choose an element directly below it. I have to choose any other element. I'm saying I can choose, again he's saying that such that no two elements chosen in the adjacent row are in the same column. That's it. I can also choose this cell and then directly this cell also. That's also completely fine. But if you will see and go and check in this question, it has a condition. Okay, I can go in this cell and the left and the right downwards, as in diagonally left and diagonally right. But in this variation, I can go on to any of these other cells, any of the other cells except the down one. I can go here, and anywhere other than the down one. Okay, and again I can just go up except from here. I can go anywhere. I can go here, I can go here, I can go here, I can go anywhere. And thus whatsoever is the minimum falling path sum, I have to, again minimum, I have to get that answer. Now for sure, the two basic words getting a minimum and having some options, these words options and minimum, these actually help us indicating that maybe a DP kind of thing can be applied here. But before even that, we will see that what actually we are doing. And again, this is the same stuff, exact same stuff which we did exactly in this problem also. We are at a cell I comma j, then we will see at what all incoming options I can take, because I know for sure that maybe I will be coming on from somewhere. Okay, I can come in from here, I can come in from here, I can come in from here, I can come in from here. And again, these are all the paths at which I am coming in from. There can be again multiple branches here. But I am saying, okay, I can come at this point I comma j from all these paths. Now I have to choose that one specific path which gives me minimum sum, and I have to make sure that I cannot include just above one. So I cannot include any path which actually enters my j at cell I minus 1. Cool. Okay, now for sure we have the intuition of why we have the intuition of DP by simply seeing the two words options and minimum. And so far, if you have already watched this, then also we have discussed the same thing in that. But still, for the folks who have not, we can simply see that at a specific point, if you land on, right, if you will reach here, you will have an option of path which you had taken, let's say this one, right? And then you again, whenever you take any path, you will keep on tracking its minimum sum. Again, the same path, again, as you can see, the same path I have taken here. But as soon as I land on here, I again can have multiple options to go to. I can go here, go here, go here, go here. So if let's say I would have gone this blue one, I'm showing if this blue one I would have gone, okay, that's one such option I would have gone in from here. So whenever I was finding the answer for blue one, this path I would be recomputing again. Whenever I would be finding an answer for this blue one, I would be again recomputing this entire path again. So you see, okay, you are recomputing. There's a sub problem which is the white one. This is the one which you are actually computing again and again for this one also, for this one also. So we realize we are actually repeating a part of the problem. We can maybe do one thing. We can save this. Okay, up till this point, this is my minimum sum, and I can give this minimum sum to this also and to this also. I don't have to compute that again and again, and I can give this minimum sum to this also this also, like anyone, I can just give him. I don't have to go and compute this entire thing again and again. That is called as the repeating subproblem. Now we are very sure that we will for sure apply DP, and as soon as we know we'll apply DP, we'll simply start solving and start building a recursion. In that recursion, we can simply add 2 lines to actually memorize that and result that as a DP. How we'll do it? We know that we have to go on to all. If we go back, we have to go on to all the indexes I and j, right? Just we have to make sure that as I am on a specific index I comma j, I have to go and ask my above neighbors that, bro, except from the one who is at the just top of me, all the other ones, bro, what was the minimum path sum up till you? What was the minimum path sum up till you? And I am the big brother. I will assume that my neighbors, or basically my small brothers, will actually give me the answer for above. I don't have to worry about it. So I will solve for this I comma j, and I will assume that above answer of the minimum path sum will be given by my brothers, by my chotu brothers. So what I did was, I went on and tried for all the possible j's, in the column in the row I minus 1, except from the j at which I am standing. So I will name this j at which I am standing right now as not j, so that I will not take this specific j altogether. Then I will go on to all these cells in the row I minus 1, which means all the cells, which means all the columns in this row I minus 1, except this column which is having a jth value as not j. And then whatsoever is the minimum path stored up till this point, I will take that minimum path and I will simply add in my current value, which is I comma j. So as to say that, okay, the minimum path whatsoever you had, I will just simply add this path. Now this is the path which will be up till this point 5, right? And again, for sure, what we are doing, I'm actually doing a solve function, which is actually finding the minimum path sum altogether. So I can simply say that from top also I can simply ask for minimum path sum, right? So what I will do, firstly, very basic base case, as I'm going on to all the cells one by one, all the rows one by one, as soon as I reach the last row, I can return something as in what? I have to return something. I know I am finding my minimum path sum. So as soon as I have reached the end, which means my path is completed. So if something is complete, please return a 0, because it is done. I should not add something more. I cannot add an int max or an int min, because I know this is done. If it is done, I'm good. So if I'm good, I should add something which should not impact my answer. And as I'm taking a sum, 0 is a value which will never impact my answer. That's the reason I added a 0. Okay. Now we for sure can add a simple if condition of dp, that if dp of I comma this specific not j. Again, Aryan, why not j? Because I am at a cell I comma not j. So, and why not j specifically? Because I know that, okay, the j which I will be iterating on the above row, in that I should make sure the jth should not match with not j. So it's the reason I'm actually currently at a cell I comma not j altogether. So I will say that for this dp of I comma not j is not equal to minus 1, just simply return dp of I comma not j. Return dp of I comma not j. Okay, yeah, dp of I comma not j. Now for sure, at this point you have to try for all the possibilities, but take the minimum one. So I initialized my answer with int max. I went on to all the columns of my cell of my row I minus 1. So you can see I am going on to all the, again, the same way can go for your dp, which is you can just simply right now say that, okay, I will take this column. Again, the same way bottom up will work, that I am at a specific cell. I know, okay, I will compute this value, whatsoever is minimum, I will just try to give it to the next cell. So I did check, okay, if j is not equal to j is not equals to not j, then I will try to get the value of sum, and I will say, bro, and try for the next cell. Again, the dp can work in both directions, top and bottom, right? So I can go on to next cell and say, bro, next cell, just make sure to not include this column altogether. So actually what we were thinking is, okay, I will, when I am computing the answer for I comma j, I can simply look back my top row and can ask, bro, have you computed, please can you give me the minimum value Or I can also say the same thing as, if I am at a cell I comma j, I will check, okay, I will, let's say, include this specific row, then I'll go on to my next row. I'll ask my answer I'll ask recursion the answer that if I go on to next row, then which means I go on to I plus 1 row, I know that this cell I cannot include, then what is the minimum path sum? What is the minimum path sum? And again, it will go down, it will go down, it can go any down, again, any down it can go, and ultimately in the end, whatsoever answer he will get, he will actually minimize that answer on all the leaf nodes. Cool. In the same way, exactly the same way as we did here also. Now, again, please don't be confused on the way I told you that I comma j, I can check for above. That is, if I have computed the value of above. That is simply saying, okay, I am at I comma j, I know what could have been the minimum value on the top. That is simply saying it's a bottom up approach. Now, if I don't even know what the answer have been computed, because I am actually starting off from the cell 0, 0. So I don't know what the answer has been so far. So I'll simply go and ask, bro, I don't know what's the answer. I'll ask recursion the answer, what the recursion can give. Now, if I am at a cell I comma j, recursion will go and say, bro, you can try for simply the next cell, I plus 1 comma j, in which j will say I will not go on to this cell. I can go on to any other cells, and then I will keep on adding the path sum. Whatsoever path sum I will get as minimum, I will just minimize my final answer with that path sum. Minimize my final answer with that path sum. This is the current cell, and I'm going and trying for the next cell, saying this is a column which I have taken. Please make sure the next time you take this column, you should not include this column. As you can see, I firstly, as soon as I go on to next row, I'm making sure that this column which my parent gave me, I should not be touching that column altogether. I should go on to all the columns other than this column not j, which actually my parent gave me in the next iteration. Cool. Now, simply that's a simple case, and simply return the answer. Now, the code is very simple, very straightforward. You can see the actual recursive case, which means solve function I and not j as it is. I initialized my n and m, then I checked for my I value. If it is equal to m, then simply return a 0. Then simply a DP case, that just to simply memorize that, and simply can also see memorize that. Else I can simply go and ask my all the columns except the column at which I landed on to. I will say, bro, currently you are at a column I comma j, you are at a cell comma I comma j, go on to the next row. Make sure to not include this column j, So I just simply passed in the current j at which I was standing at. And then ultimately I will keep on minimizing my answer, and that's gonna be a final answer. Ultimately in the end I would be getting. But in the very beginning, from the main function, what you should return, well, as in what you should pass. So you remembered that you are starting off from a cell, and then you are just giving, okay, I start from a cell, and then I just add its value, and then I can call my recursion for the next cell. So anyway you can do. In this, I did like this, that okay, I went on to all the columns of the first row. I said, okay, I will take the first cell, I will take the cell j. Again, j I'm going and try for all the cells. Again, this is first row I am trying for. I'm going on to all the cells of the first row. So this is the contribution of the cell of the first row. Imagine that this is your cell. I'm going on to this cell, adding the contribution, and then going and saying, bro, start from the next row. Make sure to not include this column. Again, same way, I will start from this cell, which is next column. I will say contribute this, start from the next row, which means next row, row 1, but make sure to not include this column. And same way, I am trying for all the columns of the first row. So again, you can also do it by any other way by yourself, but this is what I feel easy, that okay, I want to iterate on all the starting, because I can start from any of the top columns, right? In the top row, I can start from any of the columns. So I have all the options. So I iterated on all the options from the top row, and then tried for the next row, saying, please, bro, don't take this column j. Right, and ultimately getting my answer as minimum answer. Now you can for sure see I am simply trying on my I and j. My DP is actually trying for all the I and j, and in that DP, or basically recursion, I'm actually iterating on all the j's again. So it is n into n for this and O of n for this inner loop. So it will be O of n cube entirely, O of n cube. And for sure, you can simply see the space we are using is O of n into m for my I and not j. So the space will be O of n into m. Now, the exact same way, although you saw that I'm solving for I plus 1 comma j, as in like simply because I never know the answer of my parent, which is the previous one. But the same way, bottom up can also be applied here. Exactly same. It's just that at I comma j, I will simply compute the minimum now. As I was telling you in the very beginning also, that it is how the simple bottom up works. That okay, if I am at a cell I comma j, I will simply go and ask my parent, which means on the row I minus 1, I will simply go and try for all the j's except the j on which I am at. And whatsoever they gave me minimum, I will take the minimum from all of them, and then whosoever is minimum, I will add myself, which means 5, on those minimum. Out of all those minimum, I will add me. So as, because I'm ultimately only concerned about the minimum. I'm only concerned about the minimum. So the same way I will do. I have taken the exact same DP. Although you will see that I have initialized my DP with the grid value initially, because for sure I assume that okay, I can for sure be adding one value 1 2 3. This is the minimum path sum for sure at that value. That is for sure be there. A grid value will for sure be added already, or I will have to add it. So I already added that, which is grid. Now I went on to all these cells, as I was already doing earlier. Also I was going on to all these cells. But at a specific cell I comma j, I was trying for a previous row and going on to all the columns of the previous row, getting the minimum DP value for them, and then whosoever is minimum and adding myself in that DP value. That is what I was doing. So I went on and said, okay, minimum DP above, just in the above cell, above row, I will find the minimum DP value. Okay, so I will just simply go and try for my j. Again, try j equal to 0 and try j less than m and try j plus. So I'm trying for the above row all the j's. So I'm just trying for all the j's, but make sure that for the row 0 you will never have a above row. So just have a condition of I minus 1 so that you never go runtime error, like you never have a runtime error. But still, if not, then I know that I am at cell I comma j. I am trying for all the cells in the above row, right? But I should make sure except the row, except the column j, I should try for all the j's except the column j itself. Then find the minimum DP value of the above row. Okay, simply the minimum DP value of above row, and then for that specific j I'm trying for, I will try for that. Whatsoever minimum DP value I have got from the above row, I know I have to simply add my current cell, which is I comma j, in that specific DP value, in that specific minimum DP value, to get the DP value, to get the minimum DP value for this cell. So to get the minimum DP value of this cell, I will take the minimum of all the DP values here. I'll take the minimum of all the DP values here and then add this cell so as to get the minimum DP value of this cell altogether. So I will take in and I will just check, okay, that simply add DP of I plus j, simply because you remember DP of I plus j already by default was stored in the grid value. So this 5 is already being stored in very initially in the DP of I comma j. I just added the minimum DP above so as to get the new value of DP of I comma j. Cool. And ultimately, you know that you have added a I minus 1 condition. So there is a possibility that your DP value will remain as it is for the first row, right? So I have added a simple if condition that if the value is int max, please don't add anything altogether, which means simply add a 0, because I by default know that for the top row, they are by default the minimum DP values. So I added nothing in them. Cool. And ultimately, as I know that as soon as I reach the last cell, as soon as I reach the last cell, I have to get the minimum DP value because I have completed the entire path now. So as soon as I am at the last cell, I will get the minimum DP value because I know my path at the last row is completed. So, okay, on all the ending cells, all the ending cells can be all the columns. As you remember, all the starting cells can be all the columns. Same way, all the ending cells can be all the columns. So out of all the ending cells, which means all the columns in the ending cell, in the ending row, just try to get the minimum one and get the answer. Same way, the time and space will also be O of n cube, because you can see I, J, and also one more loop, which is this one. Okay. Now you are sorted, and space for sure, the same space which is used, simple 2D space of n and m. Can you improvise it? Can you improvise it? Now, what is the improvisation? Okay, you have n cube, you have n square. N cube is being used specifically because of you're iterating on, again, make sure that you look specifically what is the issue. You're iterating on all the cells I comma j, then you iterate on the previous cell, then you iterate on the previous row, and try to find the minimum dp value in that previous row. So for this cell, what you are doing is, for this cell, you are iterating on this previous row and trying to find the minimum dp value, again, minimum value in this portion. In this portion you are trying to find. I'll just simply erase it so as to make it more clear that what I'm trying to do. For this cell, I'm going on to the previous row and trying to find the minimum value in this portion. Okay. Next, let's say if I could go on to this cell, then I will try to find the minimum value of dp in this portion. Now, if I ask you that, bro, why can't you simply take a minimum value in this entire cell? In this entire row, take the minimum value and then give it to all of them, rather than computing for all the, for this cell, I will compute the minimum value in this portion, right? Now for this cell, I'll compute the minimum value in this portion, right? For this cell, I'll compute the minimum value in this portion, in this portion. So I will say that, okay, for every cell, you are repeating a O of n operation. So it is a reason a O of n extra factor is added. I will say rather what you can do is, okay, you are at a cell. Just take the minimum of all the values in the above cell. Now, your obvious question will be, Aryan, what if the minimum value is exactly at the top row? Oh, yeah, you are correct. Exactly, you are correct. Then what I will do is, okay, I will try to also find in the specific above row itself, I will also try to find what is the next minimum value. What is the next minimum value? Okay, let's say it is this cell. So now you got to know, okay, Aryan, I got your point. You are trying to say that, okay, I will take, okay, on the above row, I will take the minimum value and the next minimum value, which means smaller and second smallest value. I'll take the smallest value and the second smallest value. If I am, again, that is a simple pre-computation, right? If I am at specific row I will simply pre-compute it for the row I minus 1, so that I can use this concept for all the elements of the row I. So what I did was, I am at a row I simply checked for, okay, the smallest value. If the smallest value is at the same column, if the smallest value is at the same column J, I comma J, if it has a same column J, then I will go and directly look for the second smallest one, because I know that that will for sure be not at J, because at a single column, on a single row, single column, one element can be there, right? Yeah. So that's the reason I'll go and directly look for the second smallest column, which will be this one. I am thinking greedily. If not smallest, then second smallest. If not smallest, then second smallest. I will take it for my answer. So if I know that this is the smallest one, I cannot, again, make sure, just let's say this is 4. So if I know that this is the smallest one, I cannot take this. I cannot take this. So I will directly go and take a, let's say this would have been also 4. So I'll directly go and take a 3, which is this one. So you realize that you can simply do a pre-computation of this cell of the row I minus 1 and find the smallest and the second smallest along with their indexes. Although I will say that, okay, smallest value is required, second smallest value is required, smallest value index is required. Okay, this value is required, this value is required. This is the smallest, this is the second smallest. Now smallest index is also required. Although you might also say, Aryan, then second smallest index is also required. I will say not technically. Although in the code you will see I have taken this second smallest index also, but this is not required. Why it is not required? Because you can simply see that if I am at a cell I comma j, I only am concerned of that if the smallest element is also at the column j. I'm not okay. If it is at the column J, then directly, no matter what the column is, no matter what the column is of second smallest element, I will directly go and jump onto him. And in other case, what if Aryan, but what if this second smallest index column also became same as that of I comma j? Bro, if that is the case, if you remember, my first condition is directly go and check first the smallest index. If you are saying that the second smallest index column is same as that of the column j, which means my smallest index would not be same as that of column j. So I will directly take my smallest index element, which is SV. Cool. And that is the actual crux in which I can simply eliminate this entire code of trying on for the minimum value for a specific cell I comma j, thus reducing my complexity by O of n. How I will do it? I will simply say that, bro, I have to firstly find the smallest and the second smallest element with their corresponding indexes. Again, I repeat, index is only required for the smallest element and not for the second smallest element, but still, for uniformity, I have taken the smallest. This is the second smallest DP above, which means the second smallest value, second smallest DP value in the above cell. This is the value and this is the index. Same way, this is the smallest value in the above cell. This is the smallest value and this is the index for that. And I am saying again that I only require the index of the smallest DP value and not the index of the second smallest DP value, because this is more than sufficient. But still, for uniformity, I have taken both of them. Now, this is a very simple basic code of finding the smallest and the second smallest. Just write on Google, find smallest and second smallest in an array. You will get the exact same code. The code is very simple. I'll explain you in a bit. That it simply says that go on to all the elements of your array. Again, for me, all the elements are all the columns of the array. I will go on to all the columns. Again, for me, array is the row just above the ith row. So it's the reason I also have put in the condition of I minus 1. Then I will simply make sure I have to take the minimum. I have to take the smallest value of DP. So I will just say, okay, if the current DP value is less than the smallest value, then update the smallest value. But before updating, make sure to pass in the second smallest value with the smallest value. Okay. And what if the current DP value, which is the DP of I minus 1 comma j, again make sure I am going on to the previous row. If I am at the row I am checking for the previous row I minus 1 for the smallest and the second smallest DP value. Cool. Then I will just check for if the DP of I minus 1 comma j, if it is less than my second smallest. Again, this is an else if condition, because only after it is not satisfying my smallest condition, then it will come and check for the second smallest. That it is possible that this number DP of I minus 1 comma j, it is more than smallest but less than second smallest. Then actually I will update my second smallest value. Cool. And the same way, as soon as I update the value and corresponding index also. Now I have got in, again, I'm going on to all the rows. I have pre-computed for a specific row I will check the previous row, which is I minus 1. What is the smallest and the second smallest DP value? Now I will actually go on to all the columns of my specific row I, and I will take in the help of the smallest and second smallest DP value. So I will firstly check that, okay, bro, because why this condition, although it is not required, I have only kept it just because of the reason, because I have initialized with minus 1 and I have also put in the condition of I minus 1 here. So again, you can either handle the row 0 by some default value of 0, or you can handle these row 0 with some if conditions, or the same way I have done, that handle the row 0 with the condition that, okay, if the smallest value index, it is minus 1, which means it's a by default DP value. Okay. So I have taken, okay, if the smallest value of DP value is not equal to minus 1 and if it is not equal to j. So I'm saying that I am at a specific index, I'm at a specific column j. I will go and check for the smallest DP value index. If that is not equal to j, which means I can take that smallest DP value and I can add that in my current DP value. If it is same, then I have to for sure take the second smallest DP value. I have to for sure, again, I've added this condition, but this is not required. I have to take the for sure, I have to take the second smallest DP value. So I will simply take the second smallest DP value above. And ultimately, the exact same stuff is happening. It's just that I remove that portion of code, this portion of code, and instead I'm taking the smallest and second smallest DP value in consideration. And ultimately, exact same code here also, take the minimum in the last row. Now with this, you can see your time and space reduced, both like your time reduced to O of n square and your space reduced to O of, simply like it is again same, which is O of n square. But did you focus on one specific thing? I was repeating again and again that you are only taking in consideration the previous row. That's it. You are always taking in consideration the previous row. That's it. Which means that I can for sure and very easily eliminate the entire grid of space I was taking. So earlier I was taking the entire grid as an entire matrix, but now I realize I can take only one row, which is just handling the previous row. So I did was I initialized now taking a 1D array, saying this is the previous row for me. So as you can see, exact same code. It's just that instead of dp of I comma j, I have only taken dp of j, 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 and dp of j. That's it. The only change, just to reduce my space from O of n square to O of n. Last but not least, the most tricky part is, can I reduce the space much further? Technically yes, because again, which means I am saying to reduce the space from O of n to O of 1. And why was it O of n space required? This O of n space was required so as to find out, basically so as to compute the smallest and second smallest DP value. But I again can think of greedy, right? If I have some small value, if I have some second small value, right, again this is for a specific row. Now as soon as I go on to my next row and I'm computing my new, again as you can see, this is for, okay, imagine for the first row the values of the grid itself are smallest and second smaller, but for the next row I was actually taking in the consideration the previous values of smallest and second smallest and updating my DP value so that it becomes as small as possible. Now as soon as I go on to the next row here, then I would have taken in consideration the minimum value. Again in the above row I would have taken in consideration the smallest and second smallest again. That is what I would have taken. If I repeat again, so what happened is in the top row, in the top row, the smallest and second smallest you would have taken already, which is the grid values. As you go on to the next row, you would have computed the DP values of all these cells, and then the DP values would have been computed such that they are as small as possible. Okay, then as soon as you go on to the next row, then you would have asked your previous row for smallest and second smallest DP values, which you have already computed. So I'm saying let's club these two conditions, which means finding the DP values and then getting the smallest and second smallest DP values. So what I will do is, while finding the DP values of my specific row, I will also make sure I am parallelly computing the smallest and second smallest DP values in those DP values. Right? This is the same way saying that, bro, while computing the array itself, you keep on also computing what is the smallest and second smallest value. It is the same way saying as we used in the code, as used in this specific code. It is the same way saying that you are iterating on the array. While iterating, you are building the array and also parallelly computing the smallest and second smallest element. And that is obvious because you are simply saying that, okay, I am just finding the smallest and second smallest while I'm iterating on the array. And that is what you have also been doing so far above also. It is just that now we are actually doing it not on the array, not on the grid, but also on the DP array, which is while building the DP array itself, I am finding the smallest and second smallest, and that I can use it for my next row. So I realized I would not even need this DP array. I only need these two variables because I can just simply compute them, and these are only two things which are useful for the next row to compute their specific DP values. And DP values internally, okay, I am saying DP values, but I'm not computing the DP values. I'm computing their corresponding next smallest and second smallest. right? So what I will do in this case is that as I showed you, I will be computing my smallest and second smallest. As I showed you, this is my smallest and second one which I am actually computing, and that is computing so far. Now for the current row, you will also because you remembered that this, for the current row, you will have to compute the smallest and second smallest, right? Which will actually for the next row will be taken in consideration as for all the rows. This is the smallest and second smallest. Again, this can be a bit tricky. Understood what I'm saying? Please go back and look for what I'll say. I'll not repeat because people say please don't repeat it, but yeah, I'll not repeat it, but I'll simply say one thing, that as soon as like this is the initial S and SS value, this will be used to compute the current S and current SS value. Okay, as I've computed this current S and current SS value, I will simply assign them as S and SS, and then this S and SS will be used for the next row to compute the new CS and new CSS. Okay, as soon as these are computed, I will simply again assign them as S and SS, and these S and SS are again used to the next row to compute CS and CSS. CS says current smallest, CSS says current second smallest, SS says smallest, S says smallest, and SS says second smallest. So that is how I will simply keep on computing my current smallest and current second smallest, which is the prime aim, because ultimately in the end, in the super end row, as soon as I have computed my current smallest and current second smallest, that's gonna be my answer. So exact same stuff. This is my smallest, this is my current smallest, which is for up till so far. I will use the smallest and second smallest to compute the answer for my next row, which is the current smallest and current second smallest. And then as soon as these two are computed, I will simply assign them as smallest and second smallest and simply use them for the next row. Code is exactly same. As you can see, I've initialized, again, this initialization is out of my I loop. I've initialized them as smallest and second smallest, and then I have iterated on all the rows. Now for every row, I will have to find my current smallest and current second smallest, right? For that current smallest and current second smallest, I will take in the consideration of my smallest and second smallest, right? You remember, for finding the current smallest and current second smallest, you have to take the help of your smallest and second smallest, which is above one, which are global one. Okay, then I will go on to all of the columns. I will simply apply the same stuff, that I will firstly build my DP value. Again, remember, DP value was simple, the minimum value. DP value was simply a minimum value. Simply saying, again, if you remember how you computed your DP value, you went on to the current column and checked if the smallest value having the same column as J, then take the second smallest, else take the smallest. Now I have computed my DP value, which is the minimum to take. Again, that's a simple variable because it's a simple value. Again, for the folks who don't know, I have taken in, it's a pair. Auto is a pair because you know everything is a pair for me. But yeah, I'm concerned only about the value right now. So I have computed the value, which is the minimum value. Okay, if this value is done for me, I have got the minimum value, and now make sure this is the DP value. This is the minimum DP value which you were computing. I will use this minimum DP value to compute my current smallest and current second smallest. Now I will simply know that this is my current value of the grid. This is my DP value. If it is less than my current smallest, then update my current smallest. But as you always have been seeing, as you update your current smallest, make sure to override your second current smallest with your current smallest. And else if your this value, this new DP value, if it is less than your second smallest, then update your second smallest. So you see that I got my DP value, then this is the new DP value, which helped me to update my current smallest and current second smallest. And then now I have got my second smallest and current second smallest in the last row. I will simply use that current smallest and current second smallest to get my minimum answer, and ultimately getting the answer. And make sure as soon as every of the row is done, make sure to assign this current smallest and current second smallest to your smallest and second smallest. So I assigned these current smallest and current second smallest to my smallest and second smallest. And ultimately, as I go on and do for all the rows, I will have my answer in the end. Thus, you realized I did not use any extra space and thus got my answer in O of 1. Again, no one will tell on YouTube all these five approaches. Along with, I will highly recommend, please always go and watch this video. This is very much easier than this one. Again, the only tricking part for this one is to go on to all the 5 approaches. If you liked it, then it will be very helpful. I know, maybe Maang, but still it will be very helpful if you can please like it and share with your friends. That will be very great. Bye-bye. See you. Goodbye. And again, if you have any doubts, go and watch the Discord channel. Link will be down below. And yeah, bye-bye. Take care. Please like it if you liked it. Bye-bye.